Hypothalamus Artificial Intelligence introduces OPTEX, Optimization Expert System, the generative artificial intelligence produced by HI that allows making high-complexity large-scale artificial brains without programming, and implementing complex mathematical models from MS Word. Making high-complexity large-scale mathematical models. Filling the blanks. OPTEX interprets the implementation of a decision support system as the load of a relational information system, converting the mathematical modeling and the software production in a filling-the-blanks process. The Lan-Wan environment makes easy the simultaneous remote work of several modelers, using the power of Internet and the database servers. For example, each modeler can work on one of the submodels that integrate the full model of a company. OPTEX interprets the implementation of a decision support system as the load of a relational information system, converting the mathematical modeling and the software production in a filling-the-blanks process. The Lan-Wan environment makes easy the simultaneous remote work of several modelers, using the power of Internet and the database servers. For example, each modeler can work on one of the submodels that integrate the full model of a company. With the time, OPTEX has a data warehouse that contains mathematical objects that have been proven in real models, and that can be used to build new models. This works in the same way that in object programming, where to make the software, the programmer can use objects that work correctly. OPTEX generates structured programs for each model. They are error-free and easy to understand, because the descriptions that exists in the database are included to the program. The multilingual capacity of OPTEX permits description in multiple idioms, then is possible to have the same model in different languages. The traditional process of mathematical modeling implies that programmers, usually mathematical modelers or data scientists, must make great efforts to implement complex optimization models. The OPTEX mathematical modeling process is divided into 4 stages, aimed to fill the tables of the Mathematical Model Information System, MMIS, and create and store the data model of Industrial Data Information System, IDIS. The stage are 1. Design and conceptualization. Starting from the traditional formulation of an algebraic optimization model, the idea of how it should be stored in the MMIS must be organized. 2a. Implementation of the mathematical model in the MMIS. This process may be accelerated if the algebraic formulation is organized into tables in the MS Word or MS Excel documents used to write the model. 2b. Implementation of the IDIS data model to later create the relational tables that will store the industrial data. This information is stored in the MMIS. 3. Generation of the optimization algorithm. OPTEX automatically performs this work, integrating to source code all the elements used by the modeler, such as, for example, large-scale optimization methodologies. The whole process comes down to filling the blanks in a template, or assembling a Lego object from components built by the modeler himself. The modeler does not realize programming activities, no need to know SQL. He must be an excellent mathematical modeler that understands the concepts of high-complexity mathematical modeling. OPTEX use the same structure to storage all the mathematical components that define a decision support system. Then, the mathematical modeler can use Excel or Word templates to fill the tables that integrate the MMIS. For implementing complex mathematical models from MS Word, the stages are: First, convert the algebraic model to a formulation in MS Word, in the form of tables. Second, convert MS Word tables into CSV files in standardized ANSI format. This may require an intermediate step that goes through MS Excel tables. Third, upload the CSV files to the OPTEX database. This process is carried out with the support of OPTEX, which automatically validates that the mathematical elements are correctly formulated. Fourth, generation of the source program of the mathematical model on the selected computational platform. The second step may be shortened, loading the information from MS Word directly to OPTEX, using the MS Windows clipboard. The future OPTEX load process will be a more interactive activity via web access. Mathematical Modeling Information System. OPTEX GPT is the current research and development plus innovation project, based on artificial intelligence, focused on generating a new version of the OPTEX optimization expert system, fundamentally aimed at generating a new interface, for modelers and users, of OPTEX, based on GPT-type artificial intelligence. The process of uploading OPTEX will be a more interactive activity through generative artificial intelligence, such as ChatGPT Omnichannel 4.0. In this way, the user will be able to communicate with the OPTEX model database, and use all the documents produced by HI for the management of the system. All through a conversation, out loud if you will, with OPTEX GPT. At the limit, if the user wishes, OPTEX GPT can perform the entire process in a single step, until the results are delivered. There is no need to store intermediate results. The basis of the OPTEX GPT conversation will be based on so-called prompting engineering, called by HI as the engineering of ideas. OPTEX GPT will be a specialized generative artificial intelligence to work in the OPTEX optimization expert system environment, which will be powered by mathematical models that exist in the current OPTEX database, and of all new models that will be introduced. Technical documentation that supports OPTEX, and the mathematical models developed, and general technical information. On the other hand, from this knowledge information, OPTEX GPT will help the user build new mathematical models. Several GPT models will be developed, in order to serve users with different levels of experience. The main product is the management of MMIS, Mathematical Modeling Information System. From the correct configuration of the MMIS, the modeler will be able to configure the required algorithms, link them together, and generate the computational code of their choice. Finally, she will be ready to run the multi-problem models. The data source for building a model can be the description of the real model, and/or the algebraic formulation, and/or pre-existing models in the OPTEX database. Another of the functions of OPTEX GPT will be aimed at supporting users in specific applications, to accompany them in the process of elaboration, or selection, of mathematical models, the loading of industrial databases, and the interpretation of the results. The main product is the management of IDIS, Industrial Data Information System. This work will be advised by OPTEX GPT, based on the data model of the IDIS database. This includes the verification of the validity of the database, considering the metadata of each of the fields of the tables. As an advisor, OPTEX GPT will have access to a database of documents, some generic and some specific, to facilitate the understanding of the company-wide optimization system by the user group. Alfred North Whitehead affirmed, "Algebra is the intellectual instrument which has been created for rendering clear the quantitative aspects of the world." Thank you for your attention.